by the capacitor. So that means in AC circuit containing capacitor, the current leads the voltage. Capacitive reactance is equal to 1 upon omega C, 1 upon 2 pi mu C, and unit is ohm. So in case of DC, because frequency will be 0, Hc will find from this expression is infinity. That means capacitor blocks DC but allows alternating current to pass through. Okay. Now we shall discuss the AC circuit containing resistance, inductance as well as capacitance in series. Resistance, inductance and capacitance in series. Okay. So this is also called RLC circuit. Okay, we shall discuss the phasor diagram of phasor treatment of this case when all three are connected in series. So circuit can be like this: resistance, a coil, capacitance, inductance, and capacitance connected across source of alternating EMF. All three are connected in series. And all connected in series, then current flowing to all these is element is same. Is in magnitude as in phase. As well as in phase, the current is same and can be given by I at any instant is equal to I naught sine omega t. That is the current at any instant of time t. I naught is the p square. Now the voltage across each element will have some phase relation with the current. So we already know what is the phase relation between current and voltage. In case of resistance, so this is L and this is T, the voltage drop across R, let us call this VR, and across L, that is inductor, VL, and across capacitor, so VC. Okay, so if current is in this direction, in resistance, we know the phase relation between current and voltage in case of a resistor, which is, if this is current, this will be VR. Both are in same phase. We already have discussed the case when a pure resistor is connected across an alternating supply. But in case of inductance, if this is the voltage leading the current, that is DL by 90 degrees. In case of capacitance, what happens if this is current, then voltage will lag because current leads by 90 degrees. So that is the phase relation between the current, voltage, and in case of resistor, inductor, and capacitor. The maximum voltage across the resistor, maximum current is I naught is flowing, will be given by VR equal to I naught R. Okay, similarly, in case of, so we draw this on the phasor diagram first, and then we continue with inductance and capacitance. I draw this. This is X direction, and this is Y direction. and this is negative direction, so y dash. Now let us take the current along the x direction, I naught, and now VR will be the same. It is I naught, and the voltage across the resistor, they both are in same phase. So let us say this is VR. So it is in the same phase. So we'll show VR along the same direction as I naught. Okay, now let us call this position A. So OA now is equal to VR. All right. So now we'll talk about inductance. So BL, the maximum potential across the inductance or inductor, will be equal to I naught maximum current into the reactance, inductive reactance, that is XL. Now, because the relation between I and VL is such that VL leads the current, so therefore current is along X direction, so VL will be in the direction perpendicular to it. It leads, so it will be in the anti-clockwise. The angle will move from I naught in the anti-clockwise direction and get this angle 90 degrees. So let us say this point is B, and OB represents the VL. That is the potential drop across the inductance. So OB is equal to VL. Now in third case, capacitance, VC maximum value is given by I naught into XC. XC is the capacitive reactance. Now the relation between I and VC, because the voltage lags the current. So current in this direction, so voltage lags. That means we go in the clockwise direction. So lag, so current lags. So 90 degree from clockwise direction. Let us say this is the value of VC. So this much is VL and this much is VC. So VC is lagging, VL is leading. Now from this we can get the result. E resultant of all the voltages VR, VC and PL. From these two are 180 degree out of phase. So one is positive direction, other one is a negative direction. Then we can get resultant of these two, VL and VC. Just find out VL, because VL is more than VC. In this case, we have that we have okay. So just deduct VC from VL. तो जितना VC है उतना यहाँ से VL काट दो, यहाँ से जितना हमने VC के बराबर काट दिया, ये हट गया, ये फाइनली रह गया. So you can say this is D. So OD is equal to VL minus resultant. So draw the parallelogram and complete the parallelogram from the get the diagonal. And this diagonal gives us the E naught, that is the resultant EMF across the
सर आपकी वीडियो
in
ऑफ है।
series. E naught on है बेटा, अब ऑफ है ऑन। जब आ जाए मुझे बताना।